thank you all for joining us again on Friday, hopefully the last day of our training here. Some other things here. So I think when we left off, we were down in the Dali group. I don't know how many of you use Dali very often, but past the sort of sequence block here, what we start to get into, or the sequence folder rather, what we get into are blocks that are mostly related to devices, physical devices that exist in the program. And that would be, you know, Dali ballasts, in this case, buttons, sensors, fixtures, whatever. And that continues on in that sort of theme when we talk about RDM. So there's a little block in here for you to be able to build RDM commands, to send RDM and also to observe RDM. You're going to see that theme with a lot of our sort of serial input connections, where you'll have a send block and a receive block. Devices also, you'll see specific devices that we might have on our system. So these are all devices that I have added to the show. So we can drag one of these out and actually look at the device, see information that it has on it based on what's connected. So let me actually just make sure I have some of these devices. So ePix node is not connected, but I can get the Pixel node and the Dali node. Let's try that. Let's do Pixel. I'm skipping over Dali because it's not something we do very often. If anybody has some serious interest in Dali, let me know. We can kind of get on a one-on-one with you. And actually the best people to handle that are really our German team, because they and the European team know the most about it. I'm dangerous, enough to be dangerous at least, but without Dali devices on my system, it's kind of hard to show you exactly what a lot of those do. So yeah, so at the end of the call here, I'll leave myself a note. We'll talk Dali if necessary. If not, that's okay. So we'll talk about RDM here just for a second. I won't skip ahead of myself. So building the RDM command is a little bit challenging here, and I would recommend I'm first to tell you that I'm not an expert on this block. Obviously, RDM commands are very specific, so you can use different libraries for those commands, and specifically the type of commands that you're sending can be changed here over on the side. There's a lot of different options here. This is a great place for the manual. So if you guys have some big questions about that, let me know. But the idea basically is that we create the command within this block and then essentially send it. So here, you know, we have options to, you know, like get a device hours option. You know, we have some specific RDM commands that work for Allegro washer and liner. Some of that has to do with how we control boost mode in those fixtures. So unless you're using those, don't worry about that. But the nice thing about this generator is you can, you know, say, let's get the device hours for a UID, and you can right click and then say, hey, let's send that. We'll talk about here kind of where to put that. Along with that is our sort of send and observe RDM command. So if RDM is enabled, we can wire this in here. So we've created this command, and we can go ahead and fire this event and then also send that. Based on what we're observing, specifically the source, the UID, any single device, a group, we can listen to. So this is a great option here for, you know, if you have devices that are sending you back, you know, temperature commands, and we're observing that on the network. I don't think I need to tell anybody here, but always be a little wary of RDM, especially with dynamic systems, because RDM will sometimes get in the way of data packets, level packets, especially if you're polling a lot of that data, and give some, you know, sometimes unwanted operation of your lighting fixtures. But that, in a nutshell, is essentially how the build, send, and receive or observe commands are operating. Let's talk about devices. So we saw that my Pixel node is connected. There we go. So these observed controllers are great. In our factory show file, we've got a couple of these blocks. that are connected to text fields with some combined text blocks. You saw we were using those last time. And what that does essentially is create a little text string that says, pixel node is connected to, and a colon, and then we kind of wire this this input in. So, it's connected to IP address 192.168.1.235, which is my computer. You can get information like hardware versions, current IP address, whatever the live name is, if it's in a different run level, which means like, is it stuck in boot mode? Is it, getting a firmware update, something like that? Its current software version, also temperature, unique hardware ID, and also whether it's utilizing DHCP. This is an observe block, so no changes are being made through this block, except for restarting the device. You can send a restart trigger through this block. These blocks, like the sequence blocks, are unique to each device. So if you have 10 pixel nodes, you'll have 10 blocks that you can pull out. Important to know which is which. That's when your systems get bigger. It's helpful to start naming, using those live names and start naming those nodes. A lot of times we'll name them, about their location, and maybe if we've got like a label maker on site, you put a label on it so that it matches what the system shows. So that's the observe controller block. You can have a bunch of different information here. Just for the sake of it, let's drag out the S2. You'll notice the S2 is a little bit less available as far as information is concerned, because there's just not as much on board with that controller. It is a legacy controller of ours, so it doesn't have all the bells and whistles that the other simple nodes do. So those are observe controller blocks. We also have an observe system block, and essentially the observe system block should maybe be thought of as the observe processor block, because that's really what this is looking at. So you'll notice that if I hover my mouse over the device name section, it's looking at my desktop or my computer. It's also good to know when you have a file loaded, if you are, whatever connection or computer is processor, in this case, a Core S or LCE3, or your computer is running Sympholight, this is going to be pointed there. So, it might be showing you information about your computer, but when you upload it to a Core S, it'll be talking about the Core S itself. This is a handy one. One of your blocks, or actually one of your scripts in your script, in the link, there's 2 zip files. One of the scripts in that one is an uptime script, which takes this this calculation here and translates it into days, hours, minutes, and seconds. Get other information here, your CPU load, how much memory you're using, lots of other bits and pieces. So depending on how much information that you might want to access from your system at any one time, whatever you'd like to give to your clients. Sometimes clients love to see data, sometimes they don't. So this is a good way to get it, and to just see what's up. Obviously, the gotcha here comes like, well, if you were to see a problem or to try to determine if there's a problem, you might be able to see that the CPU load or the memory usage is really high. But obviously, if your processor isn't functioning properly well, this isn't going to help you, because you need the processor to tell it what to do. But again, nonetheless, helpful. So we get rid of this here. Receive DMX. This is helpful for, I think, one of the most basic forms of integration. So what I'm going to do is, let me see if I can connect this. Yeah, let's just make we'll go into setup, and I've got a DMX node that is not online, and I think I need to change my network ports to get to see these. So why don't let's see if I can. So essentially this block here is looking for a target, right? So because I don't have any online DMX nodes, it's not going to show exactly what the entire block looks like, but we'll kind of explain our way through it based on this port or the properties window over here. So the target is going to be whatever DMX node or whatever DMX output node you have. Good thing about our DMX devices, except the S2, again, old technology, the DMX node, the Pro node, the bridge node, you can turn your outputs into inputs. Any of them can be turned into an input. So what we'll do when we set up this block is we'll target the specific node. We'll target the output port, whether it's number 1 or number 2, if it's a bridge node or a Pro node, there's up to 8 ports. So you can choose your port. And then, or rather how many ports we're looking at. And then in this case, you'd be able to say, hey, which port are we looking at? And then we have a channel index. So the idea is which channel are we observing to look at values? So if I were to set this up, I would say, oh yeah, it's you know, we've got 2 ports here. I want to be able to listen on both my both inputs. I have a DMX node I've configured just for taking DMX in. So port 1, I want it to look for channel 240. And we'll talk about the different data types. It could be in 64 double. Double's probably better. And in this case, we can then go to the other port and then say, okay, we'll look at channel 2. So now that will tell this block what channels it's going to pay attention to on each of those incoming DMX ports. And then we can use things like condition blocks.
Hey, Chase, those inputs want to be int 64, not double. That's
noted.
Yep.
So what we can do with that is we can then go into our compare blocks and we can change our data types to int 64. And what this, we can say, okay, well, if A, which is the first input, equals B, let's make B property. Let's say when that channel reaches 255, we'll do something. So we'll write our connection in here, and once port 1 channel 240 reaches 255, we get a true. And then we can take that true and go and activate whatever we want, a sequence, a queue, something like that. So that's a great way to use DMX, a really basic way for us to take an integration protocol. Any questions about that before we move on?
Yeah, sorry. If it's a third-party device,
yes.
How would it be communicating over IP, or how would we set that target? What kind of device could we theoretically communicate with the system with, and how would we tie it in physically?
So this program is really intended to control EQ devices, right? Now, I've never actually tried this using, well, actually, I'll adjust my comment there because I answered my question in my head. We can speak streaming ACN and ArtNet, and we do, but those are output protocols. We're bugging our team, our development team, to turn those into input protocols. But if you want to receive DMX with an EQ system, you will need an EQ DMX node that you can then use as the data input.
Okay. So then that receive DMX block would be targeting a DMX node.
Correct.
Got it. Okay. Thank you.
Yeah. Okay, so we talked a little bit about some integration protocols. Let's go continue down our device list here. Dry contacts, another possible way to do this. Analog digital contacts. Let's see, I don't have much connected here that has dry contacts. So if I had an XT2, the Butler XT2, some of you people who've been with EQ for a while know of the Butler XT2. It's a kind of a mid-level controller that's meant to be either a network component or a master control device. In this case, it has 8 dry contacts. So if I were to bring that up, I would set my target to Butler XT2, and what I would get are basically 8 different outputs that are Boolean. And they would say, you know, output or input 1, 2, 3, 4 through 8. And if we saw a closure on input 1, we'd see a true. And if we saw that open, then we'd see false. You can invert that with some of our logic and condition blocks, but generally you're going to see true for closed and false for open. There's also some dry contacts that are available on some of our older servers or newer servers, much to our American chagrin, have that sort of functionality is gone from them. Analog and digital contact. This is really dependent on whether you are using our input node, and that would show you essentially all of the inputs on the input node. I don't think if I have, do I have an input node anywhere? Let's see. Oh, I have an XT2. Let's push this in here so we can talk about it. Don't have an input node on the network. Let me just look real quick and see what IPs I am talking about. I'm connected there. Yes. Okay. So wherever that input node is in my rack here is not listening. Oh, it's not lit up. There's no power. That's why. So we won't take any time doing that, but let's just go over this guy real quick so you can see what it looks like from our XT2. So you can see our dry contacts back and forth. So whenever we would see closure, we'd see these as trues or falses, depending. Analog digital contact here would be very similar. When you see digital input, you'll see 8 of these as well. And the cool thing about this block here is you can actually allow it to, you can actually look at the individual outputs. And what this will also give you is an overflow underflow option. So that will show the analog sort of digital contact is, is looking for a varied voltage. And so it's actually going to give you a number. It's going to show you in millivolts how many volts it's reading. That is set up to receive anywhere from 0.1 or 0.0001 volts up to about 11.5. It is not the input node is not rated for 24 volt dry contact. So if you need that from us, we provide an XT2. But what we would also see there is a varied voltage input here that you would see coming out of your digital input, and you could either take that number out, use a compare condition like we did here and say, well, when we get to this threshold, we can fire an event. Or on board this block, it'll also have underflow and overflow triggers that will say, okay, when it's under your target amount or when it's over your target amount, your different trigger here, different event trigger will happen. Another kind of really basic way for integration protocols. Relay nodes are very similar. This is going to basically show us the 3 relays that would be on the relay node, and they would show control for those relays so that you could tell them to close, and they would also show you a Boolean state control. Modbus, let's not get into that because I am not the man to talk to you about that. If you're interested in Modbus, we've begun that integration. It's not very far. It has to do with one of our newest nodes that's kind of designed around our Symphocities platform, so we can kind of start to integrate some Modbus control into the system. We talked about observe controller and observe system, receive DMX. LCE displays, that would be LCE 1, 2s, and 3s. 1 and 2s, actually. 3 does no longer have the display. Depending on which controller you have on site, you can actually write things directly to the LCE display. It's helpful if there's a problem. You can try to send that information out, or you can even, if you really wanted to be fancy about it, you could create text for main sequences playing or holiday sequences playing or something like that. So that's what that is. We've got our different glass touch options. Also, I will drag this out. I think, is there one connected? There is not. Let's see if I have anything on my Butler XT2. No. Do I have a bus node in here? I do. Are there? I think, yay, there we go. Good. Okay. So last touch, we're going to touch on really briefly because, pun intended, by the way. We are going to, this controller is going to go away, but I want you to know that this is here in case you have to monitor or maintenance a site that you guys inherited. So again, like all of our blocks that are specific to an existing device or a specific thing inside of Sympholight, like an existing effect or a sequence or a online device or a network device, we want to make sure that we tell the block what it is it's actually looking at. So I'm going to tell it you're looking at this Glass Touch T12. If you want to, also, if you're ever concerned or confused about which one is which, if I press one of the buttons, you will see something. There we go. You'll see that flash. That'll give you an indication of which controller is which. These are over here. You can't see them. So what we get here is a number of different things. This is a rather long list of inputs. Glass Touches technically has 13 buttons. 10 of them have labels, 1 through 10. 2 of them have labels for dimming up and dimming down, and 1 has a power button in the middle. You can use any of those buttons for any function. It seems to make sense to use them for what they're labeled for, but if you have other reasons, we've seen some job sites say, I really want 13 scenes, or I really want 12 scenes. So we'll make the dim up button and the dim down button fire a sequence. If you click on this little configuration bar here, you can choose a number of bits of information. One of them is, is there a toggle button, or rather, is that button a toggle button? And we try not to allow the Glass Touch to control its own state. And the reason for that is you don't want the controller, like one controller, controlling all of the state, because you want to make sure that if the customer pushes a button on their action pad, that it then indicates that on the Glass Touch, or what will eventually be another one of our new button stations. So we like to control this state directly, and we can show you how we do that. Obviously, we talked about in the Action Pad Designer, we have buttons that each button you can adjust the state tracking for. We had linked it to the specific sequence that button was controlling. That's obviously the best thing for the Action Pad button. But in this case, what we're going to do here, hold on, let me make some other adjustments. So you'll see over here that there is a couple options that says LED represents internal state. I don't want that, because I don't want Glass Touch to control internal state. So I'm going to uncheck all of these boxes. So let me do that real quick, and you'll see as I'm doing that, on the left side of the block, there are a bunch of input ports that are being populated. So what that is doing is it's allowing us to write in either a 0 or a 1, and that will give us direct control of that LED. And that is what we want. So the way that we typically handle this, I'm not going to do this for every button, but let's say we have, we'll have to obviously decide which buttons are going to control which sequences. But let's just say for right now, the snake mode will be button 1. So I'm going to go to the playback state output here of our control sequence, and I'm going to make a flag. And here's another great reason why we should always label these. I did not. Let's make this snake mode. There we go. We'll go ahead and delete this guy and make it again. Now our flag is a lot more telling. So I'm going to connect that playback state to my LED 1. You'll notice I can only connect things that are outputting this data type. So I'll double click here. Now you'll notice, I think I mentioned this yesterday, but we'll continue to mention it so you can get this in your head. That orange or reddish band that was around this is now gone. And the reason for that is because now this flag has actually been connected somewhere. And you'll notice that as I hover my mouse over it, this will also actually click on it once and leave my mouse hovered over it, and you will now see a little bit of information here. So the first position says main. That is the tab that the next connection, or the main, or this will show you multiple depending on how many flags you have connected. But this is saying I'm connected to a block on the main page. It is the Glass Touch T12 block, and it is specifically connected to output LED 1. So if you're ever confused where these are going, your job site or your project file gets very large, click on it once and hold it here, and this little pop-up here will tell you where it's going. So And of course, that came with me there for a second. So now, when I play this scene, which I will do right now, we'll see our playback state goes to 1, and now we're writing a 1 into LED 1, and what you can't see is that the LED is on my glass touch to my left. So this is how we handle the playback state. We connect the sequence itself directly to that LED button. That way, no matter what is telling that sequence to play, whether it's the glass touch, the action pad, or even an overzealous user playing things over here on the output tab, you will see the proper indicators light up on both your action pad or your glass touch over here, and find our action pad and look at the same thing, provided that I remember to connect that button. And I did. There you go. So snake mode is also currently playing. We see that right over here. So it's good. It's an easy way to keep control and track of things. So yeah, that's glass touch. Obviously, if you want to connect glass touch and make it also operate, we've got this flag out here. So, or this event output here. So number 1, you've got the short push option, which means just an initial push. You can go over here and connect that flag over to snake mode. So now when I push button 1, that will also make snake mode play. You can also go in here to the configuration setting and say, you can choose what options are here for different buttons. So we can say button 1 is actually, I want to be able to do a short double press or a long push stop and a long push short, or long push stop and a long push start, excuse me. What this means is that you hold it for, I think it's like 2 seconds. It will, you'll get another trigger basically in this block. So here, I'll check these so you can see what that looks like. Now I get push, long push start, long push stop, and also double press. That was actually the dim button, not the number 1 button. But so you have some other options here if you want more functionality out of that single controller with those 12 buttons. So that's glass touch. Talk about something else here. There is an IR input here. We've long since stopped selling the remotes that use the IR functionality for these. So eBay, if you really want, but don't worry, those are gone. Simple trace, we won't talk much about that. These have to do with some internal development stuff. Talk about interface. So actually, I'll leave this block out here for you guys, just in case you want an example of how that gets connected. Move this over there. Okay, so send email. This does work. Obviously, all email providers are very different, so you're gonna need a little bit of experimentation here. Again, as long as you have the right information, specifically host, port, password, to and from information, exactly how you're going to be getting that email, we can set that up. I don't have a good one to set it up here too, so I can't show you exactly what we're doing here. But if you would like to send email and you know that your server is reliably connected to the internet, you can fill this information out, definitely test it. And so basically what you can do is we can create, a value block that, helps if I spell it right. Create a value block over here. That initial value needs to be string. If it's text, it says important. Your system is malfunctioning. So we create a message. We can send that here in the body. We can also say that's the subject. So now if something happens, like one of our DMX nodes went offline, we could take one of our observe blocks. Where are you, device? Yes. So we could say we want to monitor our pixel node. And if we have is enabled, we can use a state to event block to translate. So if we are enabled, actually, it's not enabled, we want it available. available is online in this case. So we say, okay, great. If it's true, we're awesome. If it's false, I want to send this email, right? So as soon as that drops offline, we'll send this email, and then you can even use these triggers here if there was a success to write back in, some text on the action pad that says, hey, something went wrong, but we sent an email about it, whatever you want that to say. So use your imagination with that, but that's the send email block. Okay, so let's talk about any other interface parts. Yes, okay, great. So sending MQTT commands, receiving MQTT commands, this is in particular for integration with our system. The MQTT command protocol, I believe is the best way to explain that, is how we're dealing with some of our Modbus integration. So this, obviously you see these two blocks, they were missing a feature license. This is not a very widely used thing just yet. So I can't tell you too much about them, I don't really know. But if you're interested, or you have some Modbus desires, we'll kind of get in. We can get in with our team in Germany to give us a little bit more information if you are interested. And if you are, Dave is the man to talk about that. He is a good conduit to them. He's here on this call. Send UDP and receive UDP. This is a fun one. We can actually kind of test what we're doing with this here. So anyone who's not super familiar with UDP, UDP is an internet, or rather a Ethernet message protocol, or protocol in general. That's how TCP and UDP is how most computers connect and speak to each other. It's a very simple protocol or simple method for us to use for integration, chiefly because you don't need another device to translate. And so basically, if your third-party system, your front-end system, your back-end system, depending on how we are operating, if they can send UDP, all we need is a connection to their network, and obviously to be within proper network format. We can basically send messages any way that we would like to. So you'll see that the send UDP block here has a couple options when we select it. Encoding, right? Whether you're going to send ASCII characters, whether you're sending ANSI information, UTF-8, binary, whatever your encoding may be, you'll want to make sure that that is set correctly. And really all of that needs to be is the same on both of your send and receive blocks. So definitely make sure of that. The cool thing about the send and receive UDP blocks here is you can actually test your own UDP integration prior to actually getting somebody else on site. So that's very helpful. Obviously, we're going to talk to we're going to set the specific IP address that we're going to send to, and the specific port itself. This can change. Sometimes it's a great way for, depending on your complexity of your other system that you're integrating with, they may have some problems changing what their UDP or even their RS-232 or their 485 string may be. They may have very, very specific, very rigid requirements for what they can send and also what they can receive. A great part about this system is that you can really take anything you want in and you can send anything you want out. They're literally just conduits. So we use the value blocks to basically to store that information, and that kind of helps us, adapt to whatever may be there. So what we'll do real quick is let's just get a value block over here. Okay, so we'll steal a value block. We're going to make it event-based. We will put in a specific value here. In this case, it's going to be a string value. That string value, let's just say it will say sequence. And actually, why don't we just say something basic? Hello, world. So that'll be what we send. Okay. We'll connect that to our packet contents here. And what this is doing is as long as this is enabled, this is open and ready to receive. So if you want to send something to it, the best way to do that is to use these different value blocks that have an event-based instance trigger. That way you can tell them when you want them to fire based on a timed event or a button or other things, whatever you can think of. So what we'll do is let's just make sure that our sending port and we can run. And so, hold on, it doesn't want to be there. It wants the loopback port, doesn't it? 127.0.0.1. Okay, so you can see that now that I've sent that to the loopback port, we're looking on the 0.0.0.0:1337. Since we're listening on that port here, we now can see the packet contents, right? So we sent out hello world, and we're receiving hello world. We got the IP address of the sender, and we also got the sender port as well. Now you can actually create a packet filter for really, really simple integration. Maybe all you're going to do is just receive off, or whatever sort of integration, very, very basic integration protocol we can get, or rather integration message. Maybe that's just for, we just want to make sure that the main system tells us to turn off when it wants us to turn off. So we can actually put in a packet filter here, which will be, we'll just make hello world. So when we receive that, what we'll get is a trigger that happens out of here. So we can actually probably watch that in, let's do value to event state. Let's get rid of that. Let's go to our data section, and we'll take a state to event to value. Yes, okay. So we can watch and see whether we've received this or not. Let me clear this out so we actually see it change. Okay. So we'll send something else in here because it has already received. And why don't we send? Okay. So what have we received? Looks like we haven't updated yet. What have we changed? 268 packet ASCII. See here. Send in hello world again, and what we got was a true because we received the packet that we have the filter for. So you can set up the yes or no, the logic here within the actual receive UDP block, or you can handle that logic elsewhere. Give me just one sec. Hang on for just 2 seconds. Sorry about that. So this is kind of an example of an easy way for us to receive that. Now, I mentioned earlier that one of our blocks, let's see, that would be the value to event state block, is a great way to kind of use multiple options. So we can say, this is like a good way to kind of build a couple different options for your integration into your own block. So we can say, well, maybe we will say this one's hello world. Remember, these are case sensitive, so we need to make sure that they are correctly spelled and also punctuated and capitalized. Or maybe I'll get an event and a Boolean. Remember, if you want to get a new line here, just hit enter, and that will give you a new one. World. Okay. So now what we can do is connect our port here, and we can see what values we're getting. Now let me just make sure that this is spelled properly. Okay, so we can see that for some reason this isn't doing what I want it to, but this also may be a network issue that I'm having on my side. Anyway, so the idea behind this being that if you have multiple goals or multiple commands that you need to take in without using scripting, you can use the value to event state block and fill in however many things you would like to fill in here. And essentially, whenever you match this case and match this word coming from the packet contents, you can trigger or which is an event, or get a Boolean connection to this this output. Any questions on that so far? Okay. Make sure, excuse me, while I move this over here so I can see all of you, just in case. All right, so that is sending and receiving UDP commands. The idea of sending and receiving serial messages is very similar. You can also send information to and from the network. These are a little bit more complicated, and I find I've actually never used these. These are like specific network commands. If you need that, let us know. We can connect you to our friends in EQ, and they will have all the answers for this one. I believe there's also some details on these in the manual. So we'll essentially move these over here. Send and receive serial. We can't use this one right now because I don't have a serial node, a working serial node connected to the computer. But essentially what we're doing here is exactly what we're doing with our send and receive UDP commands, right? So let me see if I can actually load, hold on, remote desktop connection. Right, there we go. This is the server that is in my control rack over here. It's a little tired, it looks like. Oh, there we go. We woke up. All right, so we can look at this send receive block in real time here. So this is some testing here for some RS-232 input and button control. So what we've got is we've got a COM port. So this is a serial input that's on the back of the server. And essentially what we can do within the same block is we can send, we can also receive. Some details here, you'll want to make sure that your buffer size is correct if you have one, that your encoding type is correct if it's ANSI or ASCII or UTF-8 or binary. You'll also want to make sure that your send and receive is in the same, obviously. You've got the same thing we have here, which is search string. This is the same as the filter that was on the receive UDP block. So if you'd like to just search for a specific string, you can plug that in here. You can also look at, you can specify some information about separators to tell you when the new string has happened, your receive byte threshold, and your overall timeout. It's a little bit more specific, obviously, because RS-232 is a little more rigid than the UDP integration. Once all that information is clear and correct, you've got a port in and port out. This is a script that we made here for handling different button stations that are connected via RS-232. So this is a really cool thing. We can basically do all this integration ourselves here. You know, there's some scripting that's involved with this side, but as far as serial ports go, it really works the same way as the UDP does. If you can, as long as you know what that string is going to be, we can tell our internal blocks to look for that. And then based on whether they receive it or whether they've got a match, we can make something else happen. Let's get out of here and go back to my computer. There we go. Let's take a couple of things. We've got a write logbook block. This is a powerful block. Anything you might want to say, anything that you might want you as a programmer or some other programmer or supporting technician might want to know about how the system works, you can do through this write logbook block. In log, which I'm going to skip forward ahead here, I'm going to select all of these. You can see all logbook information that we're seeing. We've got 4 different types of information: info, warning, error, and fatal. And obviously, starting from left to right here, less important, most important, right? So here in the automation editor, we can tell the write logbook block to speak, to talk specifically of some specific statements, right? That's we write that in through the message. So you could use value blocks that say, you know, button 1 has been pressed, glass touch button 1 has been pressed. You know, that way you get some indication whether someone has opened the action pad and has pressed buttons. You can get some information based on whether we have network devices going on offline. Quick caveat there, the log already tells you whether network devices come on and offline, but anything you can think of, anything you can trigger basically with something in this automation editor, you can connect a value block and write that into the logbook. We talked about the context. This is going to say, let's see here. Excuse me, we talked about the level. So you can change your level here if you wanted to on the fly, actually change your, you could change whether you wanted to call something a, you know, info, you know, sort of the lowest level or all the way up to fatal. That's part of how we're going to handle that. In this case, you'll see debug message, warning, and error. So this won't let you go all the way to fatal. And I wouldn't recommend using debug. Message is effectively the same as info. So these 3 levels are probably the ones you want to stick to here. So write logbook, great idea if you want to kind of leave yourself some breadcrumbs. We talked about send and receive to network. All right. So as of now, are there any questions on what we talked about here in automation land? No? Okay.
Hey, just regarding ePICs.
Yeah.
I know we have a couple, like a few systems out in the wild that have ePICs, but they've been working great. They've been running away. Haven't really had to do much on them. So I wanted to pick your brain a little bit on some of the ePICs info. If you've got an ePICs block, because it's basically double the size of a universe per output, is it only really going to be able to communicate with tracks on ePICs compatible type devices, or?
Yes, correct. Yeah, it is a Traxon proprietary protocol. Actually, it's an EQ proprietary protocol. If that wasn't clear, by the way, to anyone on the call, we are Traxon EQ. EQ is our controls brand. Traxon is our lighting brand. So they're kind of a shared technology a little bit, but ultimately credit goes to EQ. So yeah, any of our Traxon fixtures that speak it or listen to it, any of our Traxon EQ devices that speak it, those are the ones we can talk to. If you want to control, like, let's say a Traxon ePICs fixture, like many of the media tubes that speak ePICs, some of our dots, you can use one of our ePICs nodes, or you can use our bridge node, which actually is set up to receive not only eNet, which is the Ethernet protocol that EQ speaks, but it is also set up to receive streaming ACN and ArcNet. So you could control ePICs devices from Traxon with a third party if you were interested. But in general, ePICs is the way that it operates in our system. It's effectively the same as DMX, except for RDM, because a lot of our ePICs, like a lot of our ePICs fixtures, excluding the now sunsetted MediaTube HO RGBW, actually have RDM communication, but RDM doesn't actually flow over ePICs, so you'd actually be talking to it with DMX. You mentioned that ePICs has more control channels. You're totally right. ePICs is basically DMX spoken faster. So we can fit up to 2048 total channels instead of 512. But it is really just ePICs. If you try to send ePICs to a DMX device, it'll either do nothing or it'll do some very crazy things. On the EQ side, though, and specifically Sympholight, you don't really need to do much except for decide whether the ePICs device that you have, which is either an ePICs node, an ePICs Pro node, or a bridge node, has which you need to basically decide what the size of your EPIX footprint is, or your EPIX universe. So back in setup land here, I've got an EPIX that isn't actually connected to the system at the moment. It is connected right now to universe 7 and 8, as you can see over in my properties window. So if I go click on universe 7 over here, you'll see that it already knows it's an EPIX universe. If you have an EPIX node, Sympholight's going to assume that you want to use EPIX, so it's going to make the universes that it creates when you bring the node into the program. It's going to make those EPIX universes. If you, I think Ivan was mentioning yesterday, let's say you just have one EPIX universe that you need, and then you wanted a DMX universe, you could actually tell this output or the other output to be DMX instead. And then it'll speak DMX, it'll listen to RDM, but you only get 512 channels. As far as how you control it, exactly the same. All that Sympholight really cares about is what it's patched to. The pixel itself within the program is